Morning, everyone. Aaron Birdie from Upstream Pittsburgh. I'm the plan build manager at Upstream Pittsburgh, and today I'm excited to talk about the 9 Mile Run Commercial Street Culvert Monitoring project that I've been working on for a little over a year now with an intern from CMU, Carnegie Mellon University, Miu Nakajima. Unfortunately, she can't be here today because she's in class, and want to make sure she can get to her classes. So I'm going to present, and yeah, I'm excited to kind of share what we've been kind of testing and piloting in 9 Mile Run. But I'll just start with a little bit of background on the 9 Mile Run Aquatic Ecosystem Restoration Project. It was completed in 2007 by the U.S. Army Corps of Engineers in partnership with the city of Pittsburgh. And at the time, it was the 9 Mile Run Watershed Association. We're now Upstream Pittsburgh, but we were also kind of integral in that project. All in all, $7.7 million project that restored 2 miles of stream, created almost 5 acres of wetlands. I think now we're up to about 10.5 acres of wetlands in Frick Park. And since we've finished that project, or since it's been completed, we've continued to maintain and monitor the stream restoration with the help of volunteers. So between 2006 and 2008, right around when the project was finishing up, the USGS had a stream gauging station at the downstream end of the Commercial Street culvert. This station was kind of set up to understand how the stream was responding to the restoration, and they collected data for a few years there. This is kind of a point of interest for us because it's been identified as a major pinch point in the stream network, as well as a barrier to fish passage. And there's a citation to a paper there for that. And in addition, it's also been identified as a top 10 flooding hazard in the city of Pittsburgh. So this image here kind of shows like a dry weather, no water on the roadway, and then on the right, that's during a flooding event where you can see the road and the guardrail are completely submerged, and that street's no longer passable, and they have to close the road down. So in August of 2023, we installed a stream gauging station at the same location that the USGS had their setup, which was really convenient. We were able to use some existing mounting hardware, which was still there over 10 years later. And this map here is an interactive map that shows the location of the data logger, as well as 9 Mile Run in our watershed. And then I think if you click, yeah, Rachel helped me set this up. If you click on the pop-up, you get the monthly averages that we've been uploading to the is it Through Request or Waters, whatever the database is that is kind of behind that. So in addition to that method to monitor the stream, we also installed a battery-powered solar 4G camera pointed at the stream. And then used an open source Python software called PyOpenRiverCam to analyze stream flow during, storm events. So this is just a section on our monitoring methods. I'll kind of walk through this quickly. In the picture, we're seeing the downstream end of the culvert, where number 1 is on the picture is where the culvert is. And then this label number 2 is the stilling well with the sensor in it that you can't see because it's buried in the stream. But let's see. And then this next picture is the data logger that sensor is attached to. It's a 4G solar powered, solar battery powered data logger. Every hour it'll upload data to Zentra Cloud, so we can view it and manipulate it and use it. And it's sampling at a 5-minute interval for water depth, temperature, and electrical conductivity. So this is a schematic kind of showing the monitoring camera setup and how the Pi Open River Cam folks recommend that you position the camera. So you want to make sure that the camera is facing the stream, getting a wide angle kind of pointed right at the stream, and then that the camera is kind of looking down towards the stream as well. Nice picture of the camera from their website. And then this is a picture of the area of interest that we were looking at. So in that previous picture, we were looking at the culvert. This is that same culvert, and then the stilling wells over there. So in order to understand kind of scale of rainfall events and flooding and things like that, we were using rainfall data from the Three Rivers Wet Weather radar rainfall website. You can download rainfall data at 15-minute intervals for actual rain gauges, and then also radar pixel data. This is just an example of the Pi Open River Cam software, some of the outputs that you can get. So these are a couple cross sections showing magnitude of flow at each section. And then this little scale bar down here shows you the velocity in meters per second. So a few more kind of examples of the visual kind of manipulations you can do with the software, and then a few more examples of the analytical features. Then I'll jump into some results of the stream gauging and then the monitoring results, and then kind of wrap up with that. So this chart shows about a year's worth of data from, I think, January 13th of 2024 through the 13th of this year. So we can see the rainfall precipitations in blue, and the depth in inches is in this green color. So the max depth that we observed is about 62 inches. Average base flow is about 23 inches. And I zoomed in on that specific event. It was about a 2-inch rainfall event. And you can kind of see the very quick response that the stream has to that precipitation, increasing almost 3 feet in depth in a matter of less than an hour. The conductivity data also is really interesting to me. There's a lot of impervious surface, there's a highway, a lot of road salt inputs to 9 Mile Run. So this graph kind of shows you again a year to date pretty much of the electrical conductivity. Before this presentation, wanted to put in some values to give context as to what a freshwater stream should have for conductivity values. I think it should be, at least in this scale of millisiemens per centimeter, about less than 1. And we're seeing about 9 times that in the snow melt, which is harmful to fish and macroinvertebrates and all the critters that we love in 9 Mile Run. The water temperature is also kind of interesting. Max temperature of 81 degrees is pretty hot in the summer. So thinking about, could we add more canopy to the stream, places to try and keep the water a little bit cooler? I think that's interesting data. And then this is the really cool part, the kind of video analysis. So this is just a video during the storm. I think it was a 0.3 2-inch storm event on May 11th last year. We grabbed the area of interest. And then this is kind of the results. So you can see in the image where flow is kind of accumulating, where it's, really focused. And there's some better examples later on of some bigger storms. And this just kind of shows when it rained and when we ran the analysis. So a little bit bigger of a storm, a little bit more rapid water. Go to this next one. So we can see kind of that difference between that first example and this example of how much flow we're getting through the channel. And what's interesting here is we see this kind of eddy forming where there's a lot of stream bank erosion happening. So this kind of validates that that water is circulating back and just undercutting the bank, over and over again. And these analyses are all kind of the same, showing a similar pattern there with that eddy forming. And I think this might have been the biggest rainfall event we observed. So yeah, we can look at those, and I'll be sure to share the link to this after the meeting so that you can kind of cruise through the story map at your own leisure. So some of the issues that we ran into, the software can't pick up on really rapid and white water. Because of this, I think this application would be better for like a long-term like base flow monitoring of streams or monitoring smaller streams, where you might not be able to get a depth measurement year round. They might dry up, something like that. The other issue is it's kind of impossible to do the analysis while it's raining. The raindrops obscure the camera, and that makes it, not able to differentiate between the stream and the raindrops. So that and nighttime are also two times that you can't really run the analysis, which is unfortunate because we often get rainfall overnight and then you can't really use any of that data. Another kind of limitation that we were working with and a recommendation for the future is we're using our phones, GPS to set control points. If we had a more accurate like RTK GPS unit, be able to get better points, better data, and have a better kind of alignment for that area of interest. And similar to that, we weren't able to do discharge measurements because we did not have, an accurate cross section to use with real world coordinates to kind of reference everything to. So in the future, that GPS unit would really be critical. This is definitely Mu's section. She kind of put the whole code base into the story map. So I'm not going to run through this, but if you're interested in doing it yourself, the code is here. It's also on the PyWork website, and all of our references and credits here. Huge thanks to West Virginia University, for funding this project. All the partners for providing data and tools, and a big thanks to Mu for all of her work on this. So thanks. I think that's it. So I'll turn it back over to Haley.
Thank you so much. We will go ahead and move on to our next speaker. So go ahead and introduce yourself. Oh, and do make sure you're unmuted.
Sorry about that. My name is Heather Holton Van Tassel. I'm the Executive Director of Three Rivers Waterkeeper, and I'm going to talk a little bit about how the GAP supported a lot of our work in identifying some spaces for restoration effort and some locations for areas of high pollution. So just a little bit about Three Rivers Waterkeeper. We do have a mission to protect the water quality of the Monongahela, Allegheny, and Ojai rivers in their respective watersheds up here in southwestern Pennsylvania. And this is because we have an ultimate vision of drinkable, fishable, and swimmable waters in our region. And we have this shared vision across the globe with members of the Waterkeeper Alliance. We are part of the Clean Water Global Movement that's shared by waterkeepers. We all have our exclusive jurisdiction where we work to protect the water quality of our region, hold polluters accountable, and do stewardship of our waterways. So you might be wondering, how do we actually protect our waterways? Because protect is kind of an arbitrary word. Well, we do it in what we call 3 buckets of work. We are actively on the water, and we do general monitoring and patrolling, looking for the good things about our waterways, looking for pollution. And we also do targeted monitoring and pollution response. And we do riparian stewardship. So thinking about small scale cleanups, large scale cleanups, as well as small tree plantings around our riparian zones. We work in the community to do community outreach, education, share our love about our waterways, as well as working to get people to feel connected to our waters. And we do a lot of community and partnership amplification. We're not the only ones working in our waters in our region, and it's really important that we share the good work that others are doing as well. And finally, we work in advocacy and really focus on our clean water law enforcement, preventing deregulation, holding polluters accountable, and really sharing our scientific expertise with our regulators so they can make better informed decisions. Most of today's talk is actually just going to be focused on the water efforts that we're doing, particularly ones that the GAPS program has helped us support. So Three Rivers Waterkeeper teamed up with the West Virginia University and the GAPS program to be able to expand our monitoring and patrolling efforts in our region, as well as helped us focus on some major industrial sites on the Ohio River. So because the little bit of increased funding, we were able to do additional focused research around some industrial sites on the Ohio River, which I'll talk about those later. They helped provide us a connection and baseline data to work with the U.S. Army Corps to explore some ecological benefits of these naturally forming deltas. And I'll talk a little bit about those as well. And finally, helped us identify a restoration site with some community partners. So we did increase our monitoring and patrolling in our waterways, and also allowed us to do that targeted monitoring pollution response. We do visual monitoring as well as water sampling. So typically when we're out there monitoring, patrolling, we do have a YSI device that we'll utilize for general monitoring, but we also use our olfactory senses, our visual senses, for us to understand when to take a water quality water grab sample and set it off for more sophisticated analysis. And we can do this by foot, we can do this by boat. The photos that I have here by boat because they tend to be more interesting. But we are along our waterways and really trying to identify the really positive things about our waterways and then help identify our problem areas as well. And with the support of all of our funders, but because we had additional support with the GAPS program, our 2024 numbers were quite good for our monitoring and patrolling. We had over 665 hours dedicated to our watershed region on the water. We took 288 water samples to identify pollution or potential pollution. And we had to report 18 violations to regulatory agencies where we found pollution and identified the source. We also do focused targeted monitoring. While we do go out there and do general monitoring, we do have some focused stuff. Here we work with Mountain Watershed Association and the Beaver County Marcellus Awareness Community on the Ohio River, focused around pretty large sites. The one is the Shell cracker plant, which you'll see in that bottom picture there. And that's where they actually take ethane or liquid natural gas, crack it under high pressure and heat, and turn out these little tiny plastic pellets about the size of a nubbin on a Lego, which will then be transported somewhere else to do manufacturing to turn into plastic materials that we use as consumers. There's a couple challenges with the Shell cracker plants. Their wastewater can have organics and heavy metals coming out of their outfall directly into our waterways, which do serve as drinking water to 5 million people. Or they can actually release the plastic pellet pollution themselves directly into our waterways as well. And once those plastic pellets or nurdles enter our waterways, they can be extremely challenging to remove from there. So it's important that we are proactive at monitoring these sites. We also monitor Styropec, which is just across Raccoon Creek from the Shell cracker plant, which is currently shut down, but they are a polystyrene producer, so they actually make styrofoam. So, and they utilize tiny little polystyrene pellets, even smaller than some of the nurdles that that the shell cracker plant is using, because they're super dense. They take them, they puff them up, and they turn it into styrofoam. And then there's also on Raccoon Creek a semi-abandoned slag pile that was originally owned by Bethesda on this site that we have been able to monitor as well. And I'm gonna do a little bit of some of the data that we collected on these sites during our monitoring, but in no way, shape, or form is it exhaustive of the work we've done around these facilities. So the first one I'm going to talk about is shell, and we're going to focus a little bit, I think I can have a pointer here. Yeah, we're going to focus a little bit here on some of just the basic water quality parameters. So this is taken from our YSI device, which is a handheld water quality monitoring device that we can drop in the water in situ and take real-time water quality parameters. We have Ohio River that includes shell, the number of times we exceeded freshwater standards. And these are freshwater standards that we found from scientific literature, not ones that are deemed by, permits for these facilities. And then we have those that we took at the shell main outfall. And what you'll find is that these are the percentage of those parameters that were exceeded freshwater standards around that outfall by shell compared to the Ohio River at large that we were sampling. And so we see that 76% of our exceedances were done by shell for pH, 65% by chlorine, specific conductivity was 66%, salinity 66%, and total dissolved solid 66%. So shell is a major contributor based on the data we have for some of these freshwater standards. What's really not a good thing, but something that's educational that comes out of this is that this is in the mixing zone. So this is before it does get mixed with the entire Ohio River. It's right around the outfall. And so it really shows that we might need to have stricter regulations for what these industries can put into our waterways, because that's really detrimental to the aquatic life right around that outfall, because it is not meeting freshwater standards in that mixing zone. And it can be really problematic when we have facility after facility after facility on our waterways. And there's very little spaces for the water to recover from this type of pollution sources. We also monitor styropec, and we have more issues with the suspended solids, which are the plastic pellets that are coming out of their waterways. We are in a current litigation with them, but we have been able to continually do monthly monitoring of their outfall to document the prevalence of plastic pellets they're releasing into the waterways. And this is continued evidence to show the importance of facilities like styropec to have filtration systems on their outfalls to prevent these plastics going into the waterways. Plastics can be really problematic. They can absorb additional contaminants and be a mechanism of transportation of contamination to other areas. Lots of aquatic life eat them because they look like delicious little eggs, and then it gets stuck in their system and they can have mortality or morbidity in their life. These particular pellets, styropec, they're actually quite dense and can get stuck in our substrate. And when they do that, they can change the density levels of our, whether it's right directly under the river, or on our riverbanks, but it can change the ground's density and the ability for plant life to actually grow, because it's changing the soil. And that can also lead to other changes in the environment as well. So they're definitely in no way, shape, or form benign. And more research is showing how they become endocrine disruptors and can potentially cause lesions on our brain. So it's really important that we note that microplastics in our system will stay forever. They just break down into smaller microplastics called nanoplastic, which can enter our bodies, aquatic life bodies. And so they're just not little tiny benign things floating around in our waterways. So it's important we prevent these from entering. We also had another site that is in this little trifecta region in a very small space, which is an old slag pile that's no longer being contributed to. So it is a legacy pollution site that we've been able to monitor. They do self-report issues with selenium, total suspended solids, and total residual chlorine. But we've also documented both low and high pH, which means that they are trying to neutralize their outflow water, and sometimes they under and overshoot. And so they're really having really large problems with their remediation efforts of this slag pile to reduce the amount of issues going into our waterways. And this is something that we've been able to work with our local regulators and provide this data so that they can work with this facility to eventually stop this issue of high and low pH there, because when we have pH issues and then some metallic issues and things like that, it can really change how the plant life around that location can survive. And so now that we talked a little bit about some of the problem issues, we're going to go into like a really exciting positive thing. And so we've been exploring naturally forming river deltas, and one of our board members introduced our waterkeeper to these really amazing little, what we call deltas, sandbars forming at the mouths of larger tributaries entering our main stem rivers. Here you'll see Pine Creek, in the large arrows, the Allegheny River in the small arrows, and then outlined in red is what we call a delta. It's a sandbar, but they're becoming these little biodiversity hotspots that actually existed before we did the whole lock and dam system and built up the edges of our river fronts. It's basically our floodplains coming back and forming these little hotspots there. So before our lock and dam system, our rivers had lots of floodplains. Sometimes they'd dry up, sometimes they'd be really deep. Different times of the year would have different things. But when we built up our systems, we lost these diverse areas. But nature has a way of forming itself, and they're reforming in small spaces. And what's really amazing about this is they currently don't impede navigation. So they're not a concern to dredge out and prevent from happening. In fact, West Virginia Research Institute through our Q connected us with Western Pennsylvania Conservancy to talk with the Army Corps about these deltas that are forming and to help us understand their importance to our region, as well as just documentation, because we don't have documentation of them in our region. And that partnership led to the Army Corps thinking, wow, this is amazing. We love telling these good stories. There's urban, floodplains forming that don't impede navigation. Like, that's a fantastic thing. And so they were able to apply for federal funding, and they were successful. And we're now going to venture into an effort to document the ecology, the hydrology, the geospatial information of these deltas. And we're going to create a report as well. So we'll have that public facing aspect, as well as the internal, more scientific aspect of flood risk, aquatic and terrestrial biodiversity, water quality, recreational fishing, equitable access to these rivers. For the first pilot study, there are only going to be 4 that we know of that we've documented here. But we're hopeful that this will lead to a lot more scientific studies of these urban riparian deltas that are forming, and looking at the benefit that they can provide to the community as well. And finally, we were able to identify restoration sites. I just showed you Pine Creek, and we deal with Pine Creek a lot. And one day during our patrols, we found that there was erosion in Pine Creek, which is along the Allegheny River. You'll see here there's also a broken pipe, which is most likely the cause of the erosion. And then, you just see a lot of vegetation really not handling it very well. And so we were able to identify it, report it to the conservation district, who worked with the borough of Etna, who fix the pipe and reinforce the bank. And so this was a huge win with just one day of monitoring, patrolling, reaching out to the right people, and then also them thinking it was a big deal, and they were able to find the funds to fix the issue. We also, though, have identified PFAS contamination in Pine Creek without an unknown source. And so this will be an ongoing effort moving forward. So stay tuned as we try and figure out where PFAS contamination is coming from, which is considered a forever chemical. They are a man-made chemical, and they're typically used in anything that's non-stick, slippery, lubricant, that kind of thing. And so we don't have a huge PFAS issue in our region. They're usually very selective sites. It's not such a concerning amount of PFAS that we needed to deploy anything for understanding, but it's a slightly higher level than a lot of places in our region. And we're just working to slowly identify that issue. And based on, the responses we get from the local regulators in the boroughs around Pine Creek, we are hopeful that we might be able to fix it once we identify it. So on that note, if you want to dive deeper into a lot of the things we talked about, or just Three Rivers Waterkeeper in general, we do have some links here. You can go to our website for general information, explore all that. We do have our reports, most of them available online that you can click on. If you want to come to an event and learn a little bit more about how to spot and report pollution, once the warm season kind of comes around, we'll have a lot of events for you that way. And then if you want to support our current campaign for a larger boat, this is our beautiful one right here, but you can see, it's not very large for when we're looking at our main stem rivers, and we want to get more people out on the water, and we want to be able to do that effectively, efficiently, and safely. Especially this time of year, to be out on this little boat, it's not very safe even for the most experienced boaters out there. So we do have a campaign to get a larger boat, and if you have the means and excitement as much around it as we do, we'd love your support. On that note, love for you to follow us, and here's my email if you don't want to ask any questions here today in front of everyone, but you were really interested about something, I'd be happy to take those answers or questions, and I'll provide the answers that I can. So thank you.
Haley, I don't know why, but your mic wasn't working, but I think you were saying thank you, Heather, and we've got Virginia coming up next.
All right. Hi, everybody. My name is Virginia McAnulty.
Oh, sorry, Virginia. I don't think we're seeing the right.
Oops, I'm not saying the right thing.
Yeah.
Oh, gosh. How about that one?
Hasn't loaded up just yet, but.
All right. Are you seeing it?
You may need to click share screen again. I'm not seeing anything.
Okay. Well, let's do that again then. I apologize. I'm clicking share, but there we go.
Ah, perfect.
Does that look better?
Yes, that's great.
Hi, everybody. Sorry about the delay. My name is Virginia McAnulty. I am the president of the Upper Chartiers Creek Watershed Association, which is the group that received the support from GAPS. And I'm the vice president of the Washington County Watershed Alliance, which is our umbrella organization. So I'm just going to give you a little bit of background on this project, and then Sarah's going to take over with the more technical description. We chose this site in Houston Borough because we had been monitoring the water there for quite a few years and had noticed that the erosion was increasing. You know, you can see from the photograph that, you know, the bank is being sucked into the creek. There were islands being formed, tree roots, that sort of thing. So one of our volunteers, Carolee Hemington, contacted the Houston Borough Councilman, Nick Galbraith, and talked to him about the possibility of creating a partnership to try to handle what was happening. It happened, just so happens that this location was right at the baseball field in Houston Borough. So Houston Borough was quite interested in getting this taken care of. So once Carolee talked to Houston Borough, a whole collaboration happened. I then got in touch with, Jennifer Dan at the Washington County Conservation District, and she introduced me to Rachel Spearnack with the GAPS program. Rachel and I talked briefly about what the problems were, and she encouraged me to apply for technical support through GAPS. Our part of the deal was that we had to recruit the volunteers, take the measurements, and submit the data to West Virginia Water Research Institute, and they would in turn supply the materials, train our volunteers, and interpret the data, with giving us in the end a formal report and a beautiful story map, which I didn't even know was going to happen, but I love it. Since then, Houston Borough has had multiple flooding events, and it has distracted them a little bit from the initial focus of the project, but they were able to use the report generated by the GAPS program to apply for 2 local share accounts in the amount of approximately $188,000. One of the grants, of course, requires matching funds, and both grants are highly competitive. So we don't really know for sure whether or not Houston will be able to secure this money, but we're hopeful. If they do, they hope to complete this project, which runs approximately 1,000 feet along the stream bank adjacent to their baseball fields and community park. They want to work on the stream, stabilizing the stream bank, put in some safe entry points for their fishermen and their community members, and of course, ensure that there are proper erosion control measures. They're hopeful that they'll be able to complete it by 2025, but they haven't yet received word that they've received the grants. So I think time is getting a little bit tight. I'm not sure they'll be able to do that. The entire project design and grant application was made by KLH engineers based in Canonsburg. They have another office, but I can't recall right now where their other office is. And now we're just waiting. We're waiting to see what happens in the future. I just want to thank everybody that helped us do this. We are an incredibly small organization. We are maybe 5 people, so we couldn't do it without the Washington County Alliance, our own volunteers in the group, the Houston Borough Council, who did not turn us away. They embraced us with open arms, and in fact have even helped us with a little fundraiser that we're having. The Washington County Conservation District for connecting me to the West Virginia Water Research Institute, 3RQ, and the GAPS program. So yeah, it takes a village. We couldn't have done it without everybody. We're very appreciative. And if you have any thoughts or questions, you can reach me through the Washington County Watershed Alliance website. And that is all I have for today. I'm going to turn it over to Sarah.
Hi, everyone. My name is Sarah Nelson. I'm a civil engineering student here at West Virginia University, and I'm also a student worker at WRI. And I helped develop the final report for the Houston Ball Field erosion study, and I also developed the story map. So starting with a little bit of background, not to reiterate much of what Virginia already said, but we wanted to address the severely eroding bank along Chartiers Creek, of course, adjacent to the Houston ball field. And we wanted to use this evidence that we gathered through this study to apply for funding. This area of interest was about a 1,000-foot reach of Chartiers Creek in Houston, PA, which is in southwestern Pennsylvania. And just as a quick summary, we conducted a small-scale erosion study with the assistance of the Upper Chartiers Creek Watershed Association volunteers. And we installed these erosion pins, conducted initial measurements, and trained volunteers to collect monthly measurements, and of course, compiled and put together our results. So we had these 3 different subsections along Chartiers Creek. As you can see, labeled A, B, and C. These were 1-foot length stainless steel tubing, and we utilized them and installed them perpendicularly to the bank surface. These initial exposed distances were about 3 to 6 centimeters. This depended on exactly how much vegetation was there. We wanted there to be more of a pin exposed in order to find the pins more easily. These pins were situated above the base flow surface water elevation just to allow for pin measurement during normal stream flow conditions. And they also had a vertical distance between the pins about 1 to 3 feet. Within each subsection, we had these pins that were installed in 2 rows of 3 with horizontal spacing of 2 to 4 feet. We had 6 pins in each subsection for a grand total of 18 pins. They were installed on April 20th of 2023, and their exposure was reported monthly by the Chartiers Creek Watershed Association volunteers. Our basic measurement protocol was where the volunteers would begin collecting these measurements 1 month post-installation, and they took really great care to minimize soil disturbances, and they took very accurate measurements. They used a Fisher Scientific digital caliper, and they also recorded weather conditions and notes regarding any mass failures or disturbances to the pins. And after these measurements were taken, the pins were usually reset to their original length as indicated in our field data sheets. But if these pins experienced a change of less than 10 millimeters, they were not reset just to minimize disturbance and error. The volunteers also took great photos and notes in the event of mass failure or other cases of pin displacement. And when pins were displaced entirely, they were generally reset in a location as close to its original position as possible. Here are the results we compiled. So these measurements were collected monthly from May to October 2023, and then the volunteers went again and repeated measurements in April 2024, which was a year post-installation. These final measurements were recorded after a winter of extremely high flows, followed by a winter of low flows, that should say, followed by significant flooding in early spring. And these 5 pins were washed out. We had 5 pins that were washed out in subsection C since the October 2023 measurement, which were not used, of course, in calculating the overall study average, since we didn't know their final measurements. In the figure to the right, you'll see that we have positive changes in brown that indicates erosion and negative changes in green indicating deposition. The most widespread erosion that we had occurred in the spring. So this was April to May of 2023. And then over the winter, October 2023 to April 2024. Our average net erosion for the first 6 months of the study was 7.35 millimeters. And the average net erosion over the entire year was 33.96 millimeters. And we had 1 pin that showed as much as 101.29 millimeters of erosion, which is roughly 4 inches. So very, very significant. Here's our results. This is the updated figure that I showed earlier. So the red pins are the ones that experienced erosion. We only had 1 that experienced deposition, but the rest in that subsection, we just completely lost the pins. Based off of all of this, our conclusions are as follows. The erosion was measured visually and numerically, as you can see, I have before and after pictures. This is subsection C, which is the one that had most of the pins washed out. And again, just to reiterate, five of six of these pins located in subsection C were washed out, indicating that it should definitely be the priority for stream bank stabilization. Furthermore, again, we had this significant flooding occurring at the site in early April. I went ahead and looked up this imaging from the Pennsylvania flood risk map. Just kind of wanted to see if this was classified, Houston Ballfield was classified as anything. And it's actually classified as a regulatory floodway. So basically it is an area, a regulatory floodway is an area close to a creek or a river that will generally flood a little bit more than the rest of the surroundings, so that the rest of the surrounding community does not, of course, experience great flooding. So it's just, this area is going to be prone to flooding, and it obviously that there is a need for support there. It's crucial that these proactive steps are taken to stabilize the stream bank, since this research points to just really devastating erosion to the area. And of course, with climate change, we're going to start experiencing even more flooding and extreme weather events, which is just going to worsen the situation here. Here are my references. Thank you so much for listening, for your attention. Feel free to reach out to me if you have any questions and read the story map. You can scan the QR code. I'll also go ahead and drop it in the chat if you would like to read more about it. Thank you.
Thank you so much, Sarah, and everyone. Extremely interesting content, and we will go ahead and get into some questions about it. We have a question from Becca, one of our hosts. What could happen if the stream bank is not stabilized? Just increased flooding? I think this was in reference to Sarah's presentation.
Yeah, so not necessarily increased flooding, but there will just be more issues I think there will just be more issues regarding the ball field. Like, extreme erosion to a park is obviously going to limit the usage of the park, and it's just for Houston, I feel that the ball field is really like, that's a good community builder. Like, people are always there, in and out of there. It would just damage the park, basically.
And I'll just
Thank you,
add on
Sarah.
to that, if you can hear me. The other issue is erosion within the stream. So all of the, I'm sorry, sedimentation within the stream. So all of the erosion washes out the sediment, and in-stream sediment accumulation can really impact macroinvertebrates. Since they live within the stream bottom and they need a lot of oxygen, it can kind of fill in their habitat with sediment, which is a major issue.
Awesome. Thank you so much. Additionally, as I read these questions, if anyone would like to unmute to elaborate or ask further clarifying questions, please feel free to do so. An earlier question from Aaron. Do you know what type of treatment system they are using for the slag pile?
I don't know every detail about the slag pile. To be honest, it is usually like an earthen dam. So they use the earth that it is also then having like a system that doesn't allow leakage. Typically some sort of covering of the earthen space, but that doesn't have like a forever life. And because these are so large, it can be really challenging for upkeep. So it still has to also get rid of water that's on the system, right? So it can't just continue to collect rainwater and runoff and stuff that is mixing with the contamination on site and hold it. It has to treat it and then get rid of it. And so that's where the issue comes from, is that it can't just hold everything back at it. We have enough water that gets runoff that has to be treated and then eliminated into our systems. And so that's where the issue is happening, not necessarily the style of earthen dam at this moment. That could be a challenge for as climate change continues and we see drastic flooding events with earthen dams. But right now it's more so they have to get rid of that excess water, that storm water that mixes with the contamination, and they have to treat it and release it. And sometimes that treatment process isn't as adequate as it needs to be to protect our waterways. I hope that answers the question a little bit.
Yeah, thanks, Heather. I was just curious because a 9 Mile Run, I'm sure you're aware, we have two massive slag piles that have one is mitigated and one isn't. And we do see kind of similar, there's no active treatment or anything going on, but if the collection system gets overwhelmed, we'll get really high pHs, high conductivity, and that's mixing right into the Mon at that Duck Hollow Delta. So I was just curious. Thank you.
I'd be happy to look into those permits because they should still have regulations for what they're allowed to discharge. Even if they don't have the proper adequate systems, they technically can have violations if they're discharging extreme levels of certain contaminants.
Okay. Thanks, Heather.
Thank you both. All right, and then also from Aaron, he had a question for Sarah or Virginia. What is growing on the banks in the area you described? Does the restoration plan include live staking to help stabilize the bank?
I can probably answer that easier than Sarah. I don't know what exactly is growing there. There's, the usual amount of invasives and that sort of thing, but there is a plan. Well, and let me phrase this carefully. So the plan that Houston Borough submitted does include plantings. I am not privy to that knowledge. I don't know what plantings they include, but I do know that our group, not the Chartiers group, but the Washington Alliance group, is beginning locations for live stake nursery so that we can provide plantings for our communities. And once I know whether or not this project is even going to move forward, because we don't even know that for sure yet. Once I know whether or not it's really going to move forward, then we can approach them again. At this point, we have a nice relationship with Houston Borough, which is nice. I mean, you don't always have a comfortable relationship with a municipality, and I really appreciate that we do have a comfortable relationship with this one. And I'm fairly confident if we approach them with an idea of live stakes and possibly even putting in one of our own live stake nurseries, that it would be well received.
That's amazing. I'm excited to hear more about the live stake nurseries. We had to order some from Ernst this year to do live staking in Fern Hollow. So it'd be great to have a local source, in the future. So that's awesome.
Sure, thanks.
Thanks, guys. All right, this one is from Samantha Spector, and she asked, in reference to Sarah's presentation, do you test the stream for total suspended solids?
So our project really was just an erosion study. Rachel might be able to add on to this a little bit more, but we didn't really do any testing.
Yeah, I'll confirm that what Sarah said, but we did kind of align the study site with where Chartiers Creek Watershed Association has some volunteers doing routine sampling. I'm not sure if it includes total suspended solids, Virginia.
It does. Well, it includes a variety of parameters, but we definitely test for total suspended solids. We have erosion issues all up and down Chartiers Creek, so it's an issue that we keep an eye on.
All right, thank you guys. This question comes from Martin, and he asked, do you affect erosion/deposition when you clamber over the bank to sit or measure erosion pins?
I feel like this is mine again. We actually do not clamber over the banks. There is an historical access point to the creek that fishermen and community members have used. And that is actually one of the things we noticed, is that our access point was becoming more and more dangerous. But if you look at the photos, you can't clamber over that bank. It's quite steep. So our volunteers would enter at the access point and then walk to the location where the pins were. So they never actually were on the banks.
All right. Okay, this question comes from Becca, and it's for Aaron. She says that you mentioned the project cost at a total of 7.7 million. Besides gaps, what other funding sources were utilized for this?
Yeah, so I can provide some clarification there. The whole stream restoration project, when it was finished, over 15 years ago, was about $7.7 million, and that was a cost share between the city of Pittsburgh and the U.S. Army Corps of Engineers, to fund that project. So this was just focused on monitoring for the past few years, and the only source of funding that we used to monitor the culvert, both with the camera and the stream gauge station, was from gaps. I think we've received, funding, or the city's received funding since 2007 to make repairs to 9 Mile Run when riffles get blown out, or, the stream bank gets, blown out in a flooding event. But yeah, that 7.7 was spent quite a few years ago. So